Good morning everyone. Welcome to the class for Target IBPS Prelims 2018, and today we are going to start with the topic of probability. Yesterday I have discussed with you the concept of permutation and combination, and probability goes along with permutation and combination. So this topic I am going to cover for you today. Okay. So probability again, when we look at the importance from the banking exam point of view, from the last 3 years we are not seeing questions from probability, but before that every paper had at least 2 to 3 questions from probability topic. So we say that we should be prepared for all the topics. You never know when the topic can come back in exam fold. Okay. So probability is one topic that is normally one concept which is considered an advanced concept by students, and many students are worried about this topic. So we'll make this topic very simple for you, make it very easy. We'll try to avoid as much as usage of permutation and combination to simplify this topic, where you can solve it by basic understanding and aptitude. Right. So normally what happens when a student looks at a question of probability, it becomes a double question for him. It becomes a question of permutation combination plus a question of probability. So he thinks that if I am not very good with permutation combination, I will find it difficult to solve questions on probability, right? But when we talk about aptitude examinations like banking, most of the questions are basic application of aptitude, where not too many formulas are there. Basic concepts, if we understand of probability, basic knowledge of different types of questions, different types of events, it will help you solve questions. Even if they are of a higher difficulty level, you will have no difficulty in solving if you understand the basics well. So that will be the goal for the class today, to understand probability basics, to understand what is this topic about, right? And then focus majorly on the types of questions which come in banking examination, right? Because our target is to clear the banking examination. So there are 4 types of questions which I will be discussing with you separately, and make sure that if you get a question like that, you will 100% solve it within 20 to 30 seconds itself. Okay. Now first let's discuss the CPP question from the previous session, that was a session of combination. So if you look at this question here, in how many ways can 0 or more pins be selected from 12 distinct pins? First of all, you observe that this is a question of combination. The moment we see the word select, in how many ways you can select, in how many ways you can choose or pick, it's a question of combination. Now what we are doing here is how many ways we can select 0 or more pins. So for 0 or more things, number of ways of selecting 0 or more things from n distinct things, 0 or more things from n distinct things. What formula did I discuss last time? That is 2 power n, as you can see here also. Number of ways of selecting 0 or more things from n distinct things is equal to 2 power n. How many things are there here? We have 12. That's a simple answer then. The answer will be 2 power 12, and 2 power 12 is equal to 4096, right? 2 power 10 1024, 2 power 11 2048, 2 power 12 4096. So the answer becomes 4096. A very simple question if you know the formula of solving this question. It's a very simple question for you. Okay. Now let's start with the fundamental concepts of probability to understand what it is. So we define probability is a mathematical way of finding out the chance of something happening. In life, number of things we see happening every day, and we often talk about what is the chance that it will, let's say, rain today, or we talk about what is the chance that India will win the match today. For example, in yesterday's match between India and Afghanistan, what was the chance earlier before the match? If someone would have asked you what is the chance that India would win the match, you would have said 100%, because the way India was performing was phenomenal before that. But if you look at the match yesterday, you say it was very unpredictable that it ended in a tie with a team like Afghanistan. So calculating chance is something that we do on a daily basis. When you start from your home, going towards your office or college or school, you talk about what is the chance that I will be stuck in a traffic jam. Clear? So chance is something that we all understand in our day-to-day life. Probability is just a mathematical way of calculating that chance. To understand what is the mathematical way of finding out the probability of something happening, the chance of something happening. Clear? So what we'll do is we'll first understand some of the basic concepts. So we say we'll first understand the concept of sample space. What is sample space? In every question of probability we will talk about sample space. So sample space is the set of all possible outcomes when an event is happening. We can first list out what are the possible outcomes, and then we can think about which outcome we want, and then we find out what is the probability of that particular outcome, what is the chance, what is the likelihood of that particular outcome. So before we find out the probability of something happening, we should always find out all the things that can happen. Suppose for example, if a match is happening between two countries, there are three possible outcomes. A country can win the match, the country can lose the match, or there can be a tie or a draw, right? So there are three possible outcomes in that case. Similarly, if you appear in an examination, there are two possible outcomes. Either you pass in the examination or you fail in the examination. If you, let's say, toss a coin, now whenever a match is happening, a cricket match, you will see that the umpires will come and they will toss a coin, and then one of the captains will say heads, another will say tails. So there are two possible outcomes. When we talk about tossing a coin, there are two outcomes, heads or tails. Clear? If you roll a dice, for example, the possible outcomes are 6. You can get the number 1, 2, 3, 4, 5 or 6 on the top face of the dice. So in any particular scenario, our first objective is always to find out the sample space. Clear? And sample space is represented as a set of all possible outcomes. For example, if we take one coin, then we can represent the sample space, let's say S, capital S, sample space can be heads or tails. So this will be the way we will represent the outcomes of tossing a coin, a set of possible outcomes, set of all possible outcomes, that is what is sample space. If you take the example of a die, the plural of which is dice, so when you roll a die, the sample space will be 1, 2, so we will write each element with and separate them with a comma, okay, 1, 2, 3, 4, 5, 6. These are the 6 possible outcomes of the event of rolling a die. Once we have found out the sample space, a set of all possible outcomes, we represent the number of elements in sample space by this n of S, where n represents number and S represents the set that we are talking about. So n of S represents here the number of elements in the sample space. We write it like this, number of elements in the sample space, this is your n of S. So this is the first thing to understand regarding probability. So once we have found out the sample space, that is a set of all possible outcomes, all the outcomes that can happen in a particular case, in a particular scenario, like appearing in an examination, in a match, rolling a die, tossing a coin, taking out a card from a pack of cards, or taking out a ball from a box full of balls. Clear? So once we know the sample space, the next thing then is to find out what is the event set. So after we found out the sample space, the event set is this set of desired outcomes, the outcomes that you desire, or we can say favorable outcomes, the outcomes that you think are favorable to you. You are looking for a particular outcome, you do not want all the outcomes. So let us say if you favor a team and the team is playing a match, you are interested in finding out the chance that your team, your favorite team, will win the match. Clear? You are appearing in an examination, your favorable outcome, desired outcome is to pass in the examination. Clear? So we should find out the set of desired outcomes. Let us say the event, let us say that there is an event E, and this event is the event of getting an even number from a single throw of a die. even number from a single throw of a die. So, that is how we define our event, single throw of a die. So, now we are interested only in what type of outcomes? The outcomes which are even numbers. Now, we know from the previous case that when we roll a die, the sample space contains 6 outcomes, 1, 2, 3, 4, 5 or 6, but I am not interested in all the outcomes. I am interested only in the outcomes which give me even numbers. So, my event set would be 2, 4, 6. So, we say that n of E is the number of elements in the event set. So, we are simplifying probability just by understanding that okay, there are two things we need to find out: sample space and event set, number of elements in the event set. That is our n of E, and once we have found out these two things, probability of an event to happen, P of E, can be directly given as n of E, that is number of elements in the event set, divided by n of S, that is number of elements in the sample space. Clear? This becomes your probability formula that can be used to solve almost all the questions which come in the aptitude exam level, like banking examinations or even railway examination. The probability of an event to happen is equal to n of E, number of elements in the event set, divided by n of S, number of elements in the sample space. Now, you understand the sample space will always be bigger. You see here, sample space for one die is 1, 2, 3, 4, 5, 6. The number of elements in the sample space in this case is equal to 6, and the event set will be smaller than the sample space, because sample space contains all outcomes, whereas event set contains only desired outcomes. Clear? So, the number of elements in the event set will always be less than the number of elements in the sample space. So, we say n of E is less than equal to n of S, number of elements in the event set will be less than equal to the number of elements in the sample space, because event set is a subset of the sample space. Clear? That means what? It means that probability of an event to happen will be less than equal to 1, because we know that the numerator is less than the denominator. When the numerator is less than the denominator, the fraction is less than 1. In the maximum case, it will be equal to 1. That will happen for a certain event. That means an event which is 100% surety. Probability cannot be negative. So, we say that it will always be greater than equal to 0. That means probability of an event to happen should be a fraction between 0 to 1. Clear? If we represent probability as a percentage, we can say that probability of an event to happen, E, will be less than equal to 100% and greater than equal to 0%. A percentage from 0 to 100, that is what we say is the probability of an event when we represent it as a percentage. Alright. Now, if we take this example that we have done here, that is sample space for a die, the number of elements in the sample space was 6, and the event of getting an even number, the number of elements in the event set was 3. That means the probability of getting an even number from a single throw of a die should be equal to n of E upon n of S, that is 1 by 2.5. We can represent probability as a decimal value, or we can also say that it is equal to 50%. So, you can see in questions probabilities will be mentioned sometimes in fractions, sometimes in decimal values, and sometimes as a percentage. Clear? So, all of these things are there, and we have to understand this basic concept. What is sample space? What is event set? Now, next part from the basic concepts of probability is to understand the types of events. Okay, some questions are there which are based directly on the concept of types of events. So, the first type of event that we should understand is what is called a dependent event, or dependent events are those events which share at least one common element. So, to understand dependent events, let us first understand it by using a Venn diagram concept. So, if I make a Venn diagram, put it in a box, this box represents the sample space. This box represents all the outcomes that are possible in a particular random experiment. I am using the word here, new word, random experiment means an experiment in which the outcome is not predetermined, and second, where each outcome has equal chances, that means equally likely outcomes. Okay. Now, so sample space is there, and let us say two events are there, E1 and E2, and these two events have some overlapping. You can see that there are some common outcomes of the two events. Such types of events are called dependent events, and the formula that we should know, that has come number of times in different examinations, is that probability. So, P stands for probability, P of E1 union E2. Now, if you do not know what is union, do not worry, just it means all. It means that the probability that E1 or E2 will happen. Okay. The probability that E1 or E2 will happen is equal to P of E1 plus P of E2. So, we find out the probability of E1, the probability of E2, and then subtract the probability of E1 intersection E2. The intersection means that both the outcomes will happen. Okay. Common elements. So, to understand this, let us take one situation and say that what is the probability, what is the probability of getting an even number or an odd number getting an even, let's say odd number, not even number, getting an odd number or prime number from a single throw of a die. So, what are we finding out? The probability of getting an odd number or prime number from a single throw of a die. Okay. Now, of a die. We know that this sample space is equal to 1, 2, 3, 4, 5, 6, and that gives us the number of outcomes in sample space equal to 6. Let us say E1 is the event of getting odd numbers. So, E1 will be equal to what? 1, 3, 5, and number of outcomes in E1 will be equal to 3. Similarly, let us say E2 is the event of getting a prime number. Now, what are prime numbers? Numbers divisible only by 1 and itself. So, the prime numbers in 1, 2, 3, 4, 5, 6 are 2, 3 and 5. Just let me erase this. Okay. So, 2, 3 and 5 are the prime numbers, and the number of outcomes equals 3. Now, do they have some common outcomes? Yes, you can see 3 is common and 5 is also common. So, we can say that E1 intersection E2 is equal to 3 and 5, and the number of outcomes in E1 intersection E2 is equal to 2. Now, if we use this formula here, we will say probability of E1 union E2 is equal to probability of E1, that is n of E1 3 by n of s 6, 3 by 6, plus probability of E2, that is again 3 by 6, minus probability of E1 intersection E2, that is 2 by 6. So, 3 by 6 plus 3 by 6 minus 2 by 6 is equal to 4 by 6, or that is equal to 2 by 3. Clear? That is how we work with dependent events, with an example also on the screen here. So please understand, dependent events are those events which share some common elements. Next type of events what we need to understand are mutually exclusive events. Now, mutually exclusive events have no common elements. They are independent of each other, so they do not have any common elements. For mutually exclusive events, we should understand that the probability of E1 or E2 happening, that means E1 or E2 will happen, is equal to P of E1 plus P of E2. Clear? So, for if there are n mutually exclusive events and for them the probabilities are P1, P2, P3 up to Pn, then the probability that either event E1 or E2 or E3 will happen, we will just add the probabilities, and that will give us the total probability. Next is the probability that either E1 and E2 will happen. So, E1 and E2 will happen, that is probability of E1 into probability of E2. Now, let us try to understand this with an example. Let us say a person goes to a mall and he has a plan of watching movies. So, there are some number of movies playing. Let us call the movies M1, M2, M3, M4. There are 4 movies playing in the multiplex in the mall, and there are some number of restaurants in the mall also. Let us call them restaurant 1, 2 and 3. Now, he is deciding what to do, to watch movies or to eat at a restaurant, but he can also decide to do both, right. So, let us say the probability of watching movie, what is the probability that he will watch a movie or eat at a restaurant? Let us say he is not, let us say what is the probability that he will watch movie M1 or eat at restaurant R2? Clear? We are finding out what is the probability that he will watch movie M1 or eat at restaurant R2. Now, there are total of 4 movies here and M1 is one of the movies. So, the probability is equal to 1 by 4, or means addition, that is plus, and there are 3 restaurants in the mall. So, we are finding out that he will eat at restaurant R2, that is equal to 1 by 3. We will say 1 by 4 plus 1 by 3, that is 12, 4 into 3, 3 plus into 4, that is 7 by 12. The chance that he will eat at restaurant M1, he will watch movie M1 or eat at restaurant R2, that is equal to 7 by 12. Okay. But suppose the question was that what is the probability that he will watch movie M1? So, he decides of doing both. He will watch movie M1 and eat at restaurant R2. So, he is now deciding that I will do both. I will watch a movie and then I will go and eat at restaurant. So, what is the probability that he will watch movie M1 and eat at restaurant R2? We will say 1 by 4 into 1 by 3, that is equal to 1 by 12. So, you can see how we work with mutually exclusive events. When we have OR, we add, and when we have AND, we multiply. Next, we have to understand the concept of, just a minute. So, the third type of event we will just see here, it is very simple, that is mutually exclusive and exhaustive. Mutually exclusive and exhaustive. So, exclusive already we have seen. What is the meaning of exhaustive? So, if E1 and E2 are mutually exclusive, mutually exclusive means they do not share any common elements, no common elements. So, if E1 and E2 are mutually exclusive events, mutually exclusive and exhaustive, we say that P of E1 or E2, that event E1 or E2 will happen, is equal to P of E1 plus P of E2, that we already know from our mutually exclusive events, that when two events are exclusive, the probability that E1 or E2 will happen is the sum of the probabilities. Same thing here also we are saying, that if E1 and E2 are two mutually exclusive and exhaustive events. Now when we say mutually exclusive, there can be n number of mutually exclusive events, but when we say mutually exclusive and exhaustive, we are talking about two events. So when E1 and E2 are two mutually exclusive and exhaustive events, then P of E1 or E2 will be equal to P of E1 plus P of E2, and this will be equal to 1. That means out of the two events, one has to happen. Such type of events where two events are there, they don't share any common elements, and out of the two events one has to happen, then such events are called as mutually exclusive and exhaustive. Clear? So what happens here is that if I know P of E1, I can find out P of E2. So P of E2 is equal to 1 minus P of E1. That is the benefit of understanding that two events are mutually exclusive and exhaustive. Let's say, for example, tossing a coin, we can get either heads or tails, and out of the two one must happen. So that means getting heads or tails are mutually exclusive and exhaustive. Let's say, for example, we talk about appearing in an examination. There are two possible outcomes, passing in the exam or failing in the exam, and out of the two one must happen. So they are mutually exclusive and exhaustive events. If I tell you that the chance that a person will pass in the examination is 70%, that means the chance that he will fail is 30%. You can subtract 100% minus 70% to find out the chance of failing, because there are only two possible outcomes, passing or failing. The content from the screen will not be removed, Akash, so it will be there on the screen, so you can go back and watch the video again to see all of these concepts. Okay, so we have discussed the different types of events that are there in probability. One is dependent events, then we have the mutually exclusive events, and then mutually exclusive and exhaustive. Alright, now let us see the previous session contest question. Let us understand this. This again was in the class of combination. What is the number of rectangles in an 8 x 8 chessboard? Now we know a chessboard contains only squares. So why am I asking you the number of rectangles? Because we should know that all squares are rectangles, but all rectangles are not squares. Let me first simplify this and make a 4 x 4 chessboard for you to understand how this thing works. You don't have to draw a chessboard every time you get this question. Once you understand the concept, it's a very easy question. So let's say that we have a 4 x 4 chessboard. So 4 columns are there, and we have 4 rows, and each of these block that you see here is a square. So if the question was about how many squares are there, still the answer is not 16. We had discussed this finding number of squares in one of the classes earlier. Probably you can go and watch it again. Now here I am talking about finding out the number of rectangles. So what happens is, when we have a 4 x 4 chessboard, let's say we can extend these lines. We get 5 vertical lines. In a 4 x 4 grid, we get 5 vertical lines, and we get also 5 horizontal lines. Now to get a rectangle, what I have to do is select any two vertical lines. Let's say I select this line. Let me just change the color and show to you. Let's say I select this line. I am selecting this line here. Okay, so I select this line and I select this line. So let's say I select two lines out of the 5 vertical lines, and I select 2 lines from the 5 horizontal lines. The figure trapped between them will become a rectangle. Clear? The figure between 2 vertical lines that I have selected and 2 horizontal lines gets you a rectangle. That means this question boils down to understanding how many ways are there of selecting 2 vertical lines from 5 vertical lines, that is 5C2 into how many ways are there of selecting 2 horizontal lines from 5 horizontal lines, 5C2. So that means the answer for a 4 cross 4 chessboard will be 5C2 into 5C2. That means an answer for an 8 cross 8 chessboard should be 9C2 into 9C2. Now NC2 formula I had given to you in the previous session, that is n into n minus 1 by 2. We can use the combination formula also, but if you know this formula it will be easier for you. 9C2 into 9C2 will be equal to 9 into 8 by 2 into 9 into 8 by 2, that is 9C2 whole square basically. So that is, you can see here 36 into 36, and 36 into 36 is equal to how much? 1296. So yes, there are 1296 rectangles that you will get from an 8 cross 8 chessboard. Okay, there will be 1296 rectangles, and this is actually a question of combination, not a question of randomly counting the number of rectangles that you have on the chessboard. Alright, now let us see the contest question for today. In a class of 52 students, what is the probability that at least 5 students have their birthday in the same month? Observe the question carefully here. In a class of 52 students, what is the probability that at least 5 students have their birthday in the same month? It could be any month, Jan, Feb, March, any month. At least 5 students should have their birthday in the same month. Think about this question, solve it and post the answer in the comment section. I will be discussing the answer for this contest question in my next video lesson. Now continuing today with the concept of probability, let us go to the types of questions now. I will be discussing with you the different types of questions, basically making you understand how to calculate sample space for each of these types of questions. So let us start with the first type, and that is question on coins. This is very simple. If we have one coin, the sample space has heads or tails, and the number of elements in the sample space is 2. When we have 2 coins, that means 2 coins are tossed together, or one coin is tossed twice, one after the other, both are same. In the way we solve the questions, both are same. Okay. So when we have 2 coins, the sample space will be in ordered pairs. Now what is an ordered pair? An ordered pair is one in which the order of elements is important. A comma B is not same as B comma A. The order is important. In the first one A is before and then B is after. In the second one B is before and A is after. They are different. That is why we will call them ordered pairs. When we have 2 coins, the outcomes will be in ordered pairs. So we will have H comma H, H comma T, T comma H, and then T comma T. The number of outcomes in the sample space here is equal to 2 square. The meaning of H comma T here, you understand, the first coin has H and the second coin has T. Okay? T comma H means the first coin has T and the second coin has H. So if you see one coin, the sample space is 2, 2 coins, the sample space is 2 into 2, that is 2 square. So when we have 3 coins, the sample space, we do not have to write down the entire sample space, I will just show you how each element will be. H comma H comma H, that means all 3 coins have H. H comma T, that means the first 2 coins give you heads and the last one gives you tails, and so on till you get T comma T comma T. All 3 coins give you tails. The number of elements in sample space will become equal to 2 into 2 into 2, because for each coin the sample space is 2, that gives you 2 cube. So when we have one coin, the sample space is 2, that is 2 power 1. When we have 2 coins, it is 2 square. When we have 3 coins, it is 2 cube. That means when we have n coins, the sample space will be equal to 2 power n. So this is how you understand the questions on coins. How will you calculate the sample space? Then based on the question asked in the examination, you can find out the event set from the sample space and then solve. So if you first find the sample space, half the work is done. This is your first type of question, that is coins. Next we will look at the questions on dice. The plural of die, that is dice. So when we have one die, the sample space is equal to 1, 2, 3, 4, 5, 6. Number of elements in sample space is equal to 6. Let us write it as 6 power 1. I hope you have understood by now. When we have 2 dice, the sample space will be in ordered pairs. Now we are not going to write down all because there are 36 outcomes. Let's show you how the outcomes will look like. 1, 1 means on the first die we get 1 and on the second also we get 1. Then we have 1, 2 and 1, 3 and so on till we get 6, 6. There will be 36 outcomes in the sample space, that is 6 square 36. When we have 3 dice, the sample space again becomes equal to 6 power 3, that is 216. It's very simple. And if we have n dice, what will be the sample space? Sample space will be equal to 6 power n. Again, once you know the sample space, half the question you can say is solved. After that, just observe what is it that you want, what is your desired outcomes, what are your desired outcomes, what is the event that you are looking for, and then solve the question. So this is the second type of question that you can get based on dice. And what you are understanding here is how to find out the sample space. The next type of question that you should be familiar with is questions on cards. When we say cards, we mean playing cards, a pack of playing cards. A pack of playing card contains how many cards? 52 cards. Okay, that we should know. 52 cards are there in a pack of playing cards. What we need to understand about them is that half of these cards are red and half are black. So 26 red cards are there and 26 black cards are there. That means on 26 cards the symbols are in red color and in 26 cards the symbols are in black color. So if someone was to ask you what is the probability of getting a red card, then the answer would be 1 by 2, 26 by 52, that is half. Clear? Now the red cards are of 2 types. What are the 2 types of red cards? You know the name of the red cards. We have hearts and then we have diamonds. Similarly, what are the 2 types of black cards? The black cards are called spades and then we have clubs. These are the 4 types of cards. Each contains 13 hearts, 13 diamonds, 13 spades and 13 clubs. Now inside each of these types we have 13 cards. What are those 13 cards? The 13 cards are ace, king, K stands for king, queen, jack, followed by the number cards. So K is king, Q is for queen and J is for jack. Ace, king, queen and jack, and then followed by number cards 10, 9, 8 so on till 2. 1 is nothing but your ace. Out of these, king, queen and jack are called as face cards, and same will be true for diamonds, spades and clubs also. That means there will be 4 aces, ace of hearts, diamonds, spades and clubs. There will be 4 kings, 1 from hearts, 1 from diamonds, 1 from spades, 1 from clubs. Clear? That is how we work out. For example, suppose there is a question like, what is the probability of getting 2 kings I am not writing the full question here, just understand what is the probability of getting 2 kings from a pack of cards. So if you take out 2 cards, what is the probability that both will be kings from a well shuffled pack of playing cards? If 2 cards are drawn one after the other without replacement, it is not mentioned here, we should understand that if it is not mentioned, it means without replacement. Without replacement means I am not keeping back the card. Listen to the whole question. If two cards are drawn one after the other without replacement from a pack of cards, what is the probability of getting two kings? Or it could be two aces or whatever, right? So, what is the probability of getting two kings? So, we should think in terms of, we are not going to use permutation combination here at all, okay? We should just think about, okay, I want two cards. So, let us talk about the first card and the second card, okay? Just write down. Now, you want the first card to be a king, and how many kings are there? 4. Out of how many cards? 52. So, 52 cards, here is your sample space, okay? So, you want the card to be a king, there are 4 favorable cards for you, any of the kings will suffice. 4 kings are there out of 52 cards, that means the probability for the first card being a king is 4 by 52, and means multiplication, okay. So, just this also note down here, whenever we have and, it means multiply or means add, okay. So, and means multiplication. Now, for the second card, I want the second card also to be a king. Now, first card I have taken out and I am calculating its probability of being a king. If it is a king, how many kings are left in the pack of cards? One king has gone out, so there are 3 kings left. So, there are 3 kings left. Total cards were 52. We have not replaced, without replacement, we have not replaced. So, the number of cards has become 51. 4 by 52 into 3 by 51, 1 by 13, 1 by 17, that is equal to 1 by 221. That means, if you try 221 times taking out 2 cards from a pack of cards, then it will be possible that once you will get a pair of kings, okay. That is what we mean by this probability. So, this is the third type of question, a very common and popular type of questions that come in competitive exams such as banking, questions on playing cards. And the fourth type of question, which is again very common and popular and most frequently asked also, is questions on boxes and balls, boxes and balls. And I will explain this to you with the example of, with the help of an example itself. Let us say this is a box, and this box contains 8 red balls and 6 black balls. The moment you say 8 red balls and 6 black balls, your sample space becomes equal to total number of balls, total number of balls. How many balls are there? 14, okay, out of which 8 are red and 6 are black. Now, let us take an example question. If 2 balls are drawn, if 2 balls are drawn, what is the probability that both are red? What is the probability that both are red? Now, just like we have done the question on cards, same way we will do this also. We will think about the first ball and the second ball. The first ball and second ball. Now, I want the first ball to be a red ball. Now, total how many balls are there? 14. So, our sample space is 14. Any of the red balls will do. So, we have 8 favorable outcomes, 8 by 14, and means multiplication. Again, there is nothing mentioned in the question, that means it is without replacement. The replacement is not happening, otherwise it will be very explicitly mentioned in the question. Now, when you have taken out one ball, the number of balls left in the box is only 13, and out of which only 7 are red. So, 8 by 14, 7 by 13, so 7 will cancel 14 2 times, 2 will cancel 8 4 times, and the answer will become 4 by 13. That is how you approach a question on boxes and balls. Clear? If you take one more example to understand one more concept here, same thing, if 2 balls are drawn, what is the probability that, so I am not writing the whole question, what is the probability that one is red and one black? So, the same question, just I am changing the last part. If 2 balls are drawn from the box which contains 8 red and 6 white balls, what is the 6 black balls, what is the probability that one is red and one is black? So you just pay attention what we are going to do. If you are using permutation combination, what will happen, that also I will show to you. Just understand here, first ball and second ball, I don't prefer using permutation combination. Advise most of my students also not to do that, because unnecessarily you are making a question of probability a double question, a question of permutation combination plus probability. Okay, so we will just use fractions and solve. So we are taking out two balls, first and second. I want one red, one black. Let us say the first one is red, second one is black. When I was taking out the first ball, there were 14 balls in the box. I want it to be red, so there are 8 favorable balls, so 8 by 14 into, and means into. For the second ball, the number of balls has reduced to 13. I want the second ball to be black. The first ball was red, it has not disturbed the number of black balls, number of black balls remains 6, so 6 by 13. But what we have done is we have assumed the first one is red, second one is black, but the question does not say that. The question simply says one is red and one is black. There are two possibilities, the first one is red, second one is black, or the first one is black, second one is red. So there are two possibilities, so we should multiply with 2. 2 will cancel 14 7 times, and when you multiply nothing else can be cancelled, so 8 into 6 48 and 7 into 13 91. So answer will become 48 by 91. Look at these two questions. How do we work out? Now if you are calculating using combination, in case you want to, and you want to solve this question using combination, one red, one black, one red, one black, there are 8 red and 6 blacks. 2 balls are drawn. First of all, you see, if 2 balls are drawn from 14 balls, how many balls are there? 14. Total number of ways of doing that is 14C2. Taking out 2 balls from 14 balls, 14C2. I want one ball to be red, one black. How many red balls we have? 8. So 8C1 into, how many black balls we have? 6. 6C1. So that will give you the same answer, 48 by 91. 8C1 into 6C1 by 14C2. It will take more time to solve this question because you have to use combination, lots of calculation will be there. That's why I advise you to use this direct fraction method that I am using. So I have discussed with you the basics of probability, types of events, as well as types of questions which normally come in exams. Just go to the video lesson, you will understand every concept that you need to solve questions on probability in competitive exams, particularly like banking. Okay. So now is the time for the class practice pack, where I have 10 questions for you from the topic of probability. From the concepts discussed in the class, you can try solving those 10 questions. If you have passport access, once you hear the sound, you can start solving the question. I will be discussing the solution for the question that most of you get wrong in my next video lesson. So best of luck to you and thank you.